Assalamu students. Today's topic is going to be about numericals, motion and force. For the first numerical, we have an object which is falling under the action of gravity, and how much distance will it travel in the second and the third second of its journey. The answers are 15 meters and 25 meters. Now student, let's assume that this is a body, this is a rock which we want to find out that when it falls like this, and when it falls, how much its displacement will be in the second and the third second. For this, we must have a stopwatch, which is on the right. It is basically a special kind of stopwatch that basically measures the time in seconds. So this is 1 second, 2 seconds, and 3 seconds. Solution: the acceleration due to gravity is 10 meters per second square. The initial velocity is 0 meters per second because in the start it was at rest. In the second time, we have to calculate. In third second, we have to calculate that as well. Now let's assume, because it has to travel a lot of distance, so let us look it from far away so that we can have a better view what is going through. So for the first second, let us calculate the velocity and the displacement for the first second, which is represented in green color. For the first second, we are using the second equation of motion, which says S is equal to Vi into t plus half at square. Because it is falling under the action of gravity, so we are taking G as 10. So S1 is equal to 0, which is the initial velocity, into the first second plus half into 10 into 1 square. So this whole thing will be 0 because it is multiplying by 0. So this will be gone. Now the only thing which is left is 1 over 2 into 10 because the square of 1 is 1. So 10 divided by 2 is 5 meters. So the body which travels from here to here to a certain point after 1 second like this, it is going to be 5 seconds. As you can see over here, it has traveled 5 meters in just 1 second. We have basically stopped the time at this moment, that at 1 second it displaces this much. Moving on to the second part, for the displacement in the second, that means the displacement after second, that means the second time has passed like this. The second time has passed and the body has reached up till here, and we have to show that it has covered this much distance, which is 20. How? Again, by using the second equation of motion, which says S is equal to Vi into t plus half at square. So the initial velocity from the start part was 0. Let me clear it out for you. So the initial velocity was 0 in the start. So here it is 0 again, so it will be cancelled. Now the time we have taken is 2 seconds, and it will multiply by 10, and it will be 2 square. That means 4 multiplied by 10 is 40. 40 divided by 2 is going to be 20 meters. So the distance traveled from this point, the point of start, to the point at which it is at right now is 20 meters. So how much it covered in just this much time, from 1 second to 2 seconds. So for that, we have to measure the distance from here till here, because this much distance we have already seen that it has covered the distance in 1 second. Now for this, we have the total displacement, which is 20 meters, and we have already calculated the distance for 5 meters. So how much this distance will be? It will be S2, the distance from here, from the first second where it ended to the second where it begins basically. So S2 will be equal to 20 minus 5, which is equal to 15 meters. So this yellow line is showing 15 meters. So let us calculate over here, as S1 is equal to S1 plus S2. So S2 will be equal to S1 minus S minus S1. So S2 will be equal to 20 minus 5, which is equal to 15 meters. So the second displacement is 15 meters, and that is why we have calculated the second is 15 meters right over here. Let me clear it out a little bit. This is the answer, 15 meters for the second, from here till here in 1 second. Now for the third second, how much it will reach in the third second? For this one, again, we have to look at the diagram. For the third second, we have seen that a displacement or the distance traveled after third second is again solved by the second equation of motion, which is equal to S is equal to Vi into t plus half at square. Again, we are taking it from the start. From this point, the initial value, the velocity is going to be 0. So S will be equal to 0 into 2 into half 10 3 square. That means the third time, the total time was 3 seconds. So we'll take square of it. So it will be 9 multiplied by 10, 90 divided by 2. It is going to be 45. That means this much displacement, that means it took from here to here, it is going to be 45 meters in total. But we have to calculate the displacement in just third second. Yes, from here. So it is total time is in this case it's 3 seconds, but we have to calculate the time for the third second from here till here. So what will be the distance? So this much distance was equal to 20, or 5 plus 15 is equal to 20, and we'll subtract it by 45 meters. So what do we get? Yes, we'll get S3, which is equal to 45 minus 15 minus 5, which is equal to 25 meters. So over here in the calculation also we can see S is equal to S1 plus S2 plus S3, which is in different colors. So if you calculate for the first second, it is green color. It basically covers 5 minutes or 5 meters. For the blue color, it is for the second second. It has covered 15 meters in that time, and in the third second it has covered 25 meters in just 3 seconds, and that is why it is written 45 minus 15 minus 5 is equal to 25, and that is our answer as well. So in this way we can solve the numerical of chapter number 3, you can say it, and it is about force and motion. Let us look at this question now. This is very interesting question. It says a helicopter is ascending vertically at the speed of 19.6 meters. When it is at the height of 156.8 meters above the ground, a stone is dropped. How long does the stone take to reach the ground? And it says that answer should come 8 seconds. Now look at the scenario in this case. First of all, let us look at the scenario. This is a helicopter, and this is a stone which is about to be dropped. It is very large, so we'll make it small. Here it goes into the helicopter. Now he says the helicopter is ascending vertically with a speed of 9.6 meter per second. So the question is a little bit wrong. We can write down meter per second. So it is the velocity in this case. So it moves up like this, and the stone is thrown, and the stone goes down. So what basically is the time of that stone when it got up like this and then got down? That is the time which we want to calculate. Now let us look how we can solve this question. The helicopter is ascending from point A. When the stone is dropped from point A, it will not come down directly, but it will rise to the maximum point up to point B and then will fall freely. That means it will go up first and then it comes down, just like this. When it goes up, the phone is going up due to inertia and then comes down. Now in this case, let's assume the initial velocity we have is 19.6, which is given to us at point A. Let's call this point A, and the stone after reaching this point reaches up to point B. So the helicopter stops over here. It covers a distance of 56.8 meters, and it has a velocity of 19.6 meter per second, and the stone is reaching at point B. Now in this scenario, the initial velocity which we had was 19.6 meter per second. The final velocity of that drop will be at this point, which will equal to 0, because at maximum point the velocity will become, the vertical velocity will become 0, and at this point the body will basically stop and then come back to the earth again. Now the time taken from A to B, let us calculate the time from A to B. How can we calculate that? By using the first equation of motion, which says Vf is equal to Vi minus At. Why we are saying minus? Because we are going against the gravity. So the Vf, as we know, is equal to 0. So we put in 0 is equal to 9.6 minus 9.8 into t. So we are calculating the time over here. How much time will it take? So if we take 9.8 to the other side, it will be 9.8 T1 is equal to 19.6. We want to calculate T1. So taking 9.8 to the other side, it will divide. T1 will be equal to 19.6 divided by 9.8. The answer is 2 seconds. That means it will take 2 seconds to reach from point A to point B, which is shown by yellow color. Now for the height part, how much height did it travel from here to here, from point A to point B? For that, we are using the third equation of motion to find out the height h1, and how much is the height from here to here in time 2 seconds. Now we have to h1 vf square minus vi square, putting in the value of g, which is 9.8. 9.8 is basically the acceleration due to gravity, because we are going against the gravity. That is why the negative sign is over here. h1 is basically the height which we want to basically find out from point A to point B. The final velocity again is 0 minus the initial velocity, which is taken to be 19.6 whole square, which is in the formula. Now putting in the values, what do we get? We get 9.8 multiplied by 2, it will be minus 19.6 is equal to minus 19.6 into minus 19.6. That means the negative sign will go over here, and because we are taking square, I'm writing it 2 times, 19.6, and this is 19.6, not 9.6. Okay, yes. So this 19.6, let's cancel out this 19.6 with this 19.6. So what we are left, and the negative sign also cancel, sorry, the negative sign is also cancelled. So in this case, the negative sign is also cancelled. So what do we get? h1 is equal to 19.6 meters. That means this much height will be equal to 19.6 meters, like this. So let us color it green, that this is the height. Now in this case, how much will be the total height? It will be h dash, that means equal to, let's call it h dash, the ascending of the helicopter, how much distance is ascended. It was given to us, it was 156.8 meters, and the stone basically travel another 19.6 meters so that it can reach its maximum height. Now what is the total height? The total height will be at h dash plus hi, or you can say h1. In this case, you can say h1. So it will be 156.8 plus 19.6. The answer will be 176.4 meters. That means if we remove this, we can just simply say the stone has reached a height of 76.4 meters. Now we have to calculate the time when it already reached over here, but now it has to go down. How much time it will take from point B to point C to the ground? We have to calculate that for T2. That means the time taken from point B to point C. That is our requirement also. So from here, we basically take the initial velocity, because we are starting from here. So initial velocity, because it is starting from the top, it is taken to be as 0. We have the initial velocity for the down motion now, and we are using the second equation of motion, which said it is equal to vi into t2 plus half into gt square. Now we have to find t2. So the total distance was 176.4, because the total distance from here to here is 176.4. The vi is 0 because the initial velocity is 0. T we have to find out. The value of g is taken to be as 9.8 meter per second. Now we have to basically divide by 1 by 2. So this is 1 by 2, not 71. This is 1 by 2. Right over here. Now what do we get? If we divide 1 by 2 by 9.8, so what do we get from here? So if T2 is gone, basically this whole thing is equal to 0. So this thing is cancelled, and we cancel this 2 with 9.8. The whole answer will be equal to 4.9 into t square. Now if we have to find the t square part, what do we get? We get t2 square is equal to 176.4 divided by 4.9. What is the answer? The answer is t2 square is equal to 36. be taking square on both sides, taking under root on both sides. Let's take under root on both sides. Let me put the sign of under root over here and over here. So under root of 36, we know that is basically 6 seconds. So T2 is equal to 6 seconds. So this is the time, 6 seconds. So what will be the total time now? The total time will be this 2 second and this 6 second. That means that is the total time now. For that, we are cutting it red, separating it so that we have the total time clearly to us. So the total time will be T1 plus T2, which will equal to 2 plus 6 is equal to 8 seconds. So that is how we calculate the total time for that rock to reach the ground in just 8 seconds, and that is our required answer as well. Moving on to the next question, which is also very easy. A car moving at 20 meters per second with a, you can also say it is 72.0 kilometers per hour, crashes into a tree. Find the magnitude of the average force acting on the passenger of mass 70 kilogram in each of the cases. Now, the passenger is not wearing a seatbelt. He is brought to rest by a collision with windshield and dashboard that lasted 2.0 milliseconds. So students, it is M and it is representing milli. What does milli stand for? Now milli is a prefix basically. So let me write down. Milli means basically in scientific notation, if you want to write it down, like as 10 to raise power minus 3. So, or you can say you can divide 1000 to get the value of milli. Now, let's assume that this is a car which has to be crashed into a tree, and this is a person who's sitting and driving, and when the car basically crashed like this, he crashes right into the windshield, and how much basically the force is there to basically on the body, which body feels while crashing into the tree or onto the dashboard and windshield. Now for that, let us assume the equation. First we'll find out the data, which is initial velocity, which is given to us, which is 20 meters per second. Because the car crashes, the final velocity is equal to 0 because it stopped, and the mass is equal to 70 kilogram, which is the mass of the person, and the time t1, because we are concerned with the first crash of the person, which is basically hitting the dashboard and windscreen, which is given to us, which is 2 into 10 to the power minus 3, where 10 to the power minus 3 means milli. Now the formula of force and momentum is given as F1 is equal to m Vf minus mvi, that means the final momentum and initial momentum divided by time. So that is why we are writing down F1 is equal to 70 into 0, because the final velocity, because it got rested and it was at rest, and that's why the whole thing basically vanishes, because it's multiplied by 0, minus 70 into 20 because it's the initial velocity divided by, so it is 2 meters. So let's write it down, not 20, but let us write down 2. Let's put a point over here. It is 2 meters. Is so 2 seconds basically. 2 seconds into 10 to the power minus 3. So our answer of force is going to be minus 7 into 10 to the power 5. So what does minus mean? That means it is the force exerted on the windshield, and it basically responds back, and that is the force. The negative sign is showing the reactionary force of the windshield and the dashboard basically, and that is our required answer as well. Now similarly, there's another question to this question as well. The car is equipped with the passenger side of airbags. The force due to the airbag is acts on 45 millisecond. Okay, it acts in 45, bringing the person to rest. That means again the final velocity is going to be 0. So this answer of ours is basically not 10 to the power 5, it is basically 10 to the raised power 5, like this. And the next answer is not 10 or 104, it is basically 10 to the raised power 4 Newton. So that answer, basically we got that right answer in the first case. Now for the second case, we are solving it for part B. That means the car is equipped with a passenger side airbags. The force due to the airbag acts on for 45 milliseconds, bringing the passenger to the rest. Let's say this is the steering which we are talking about, and the passenger basically goes on to over here with some velocity of its inertia, and this airbag basically pumps out from here and basically stops its force in motion. So let's say this is the airbag basically which comes out, and the person basically is stopped by this airbag. Now, its time is given to us, which is T2. For T1, it was the person which was hitting the windshield and the dashboard. T2 is that time for that person which is hitting the airbag, which is 45 millisecond, which is equal to 45 into 10 power minus 3. Why it is minus 3? Because it is given in milli. Again, we are using the formula because we are talking about the second person. We are writing down F2 before we are talking about the first person. So we are writing down F1. So F2 is equal to M into FV or VF minus MVI divided by Q2. Now in this case, putting in the values, what do we get? F2 is equal to 17 to 0. So this whole thing will become 0 minus 72 divided by 45 into 10 power minus 3. So our answer comes minus 31111.11111. That means it is 31,111 newtons, and we can write it down as F2 is equal to 3.1 into 10 power 4 newtons, and that is how we get the answer, which is our required answer, that it is 3.1 into 10 power 4 newtons, and that is our correct answer. Now students, I want you to focus on the screen in question number 4. Very simple exercise of questions and formulas. A 0.4 kilogram ball traveling with a speed of 15 meters strikes a rigid wall and rebounds elastically. If the ball is in contact with the wall for 0.045 seconds, what is the part A? It has two parts: the momentum impart to the wall, and B, the average force exerted on the wall. The answers are 12 kilogram per meter per second and 266.7 newtons. That means the momentum is basically 12 kilogram meter per second, and the average force is taken out to be 266.7 newton. Now let us calculate how this answer come into being. First of all, let us imagine that we are talking about a wall and a ball. The ball basically goes and hits the wall and comes back. Now in this case we have a data. The data says the mass of the ball is 0.4 kilograms. It is traveling with a velocity of 15 meters per second. Time duration of contact: when it contacted the ball, it contacted it for 0.045 seconds. We have to calculate two things. We have to calculate the momentum and we have to calculate the average force as well. So the formula for calculating the momentum is change in momentum is MVF minus MVI. That means the final momentum minus initial momentum. Now what was the difference between the two? Yes, the direction is also changed. So in the first part, when it was going towards the ball, we are taking it VI, that means the initial velocity was in this direction. And in the second case, when it strikes back and comes back to us, it will be minus MVF. The minus sign, what does it mean? That means the direction has been changed. When it was going towards the wall, we take it as positive, and when it basically comes back, we take it negative. Now, what is the condition in this case? We are taking the velocity has changed the direction. So the direction in physics basically is represented by negative sign if it is against something. So in this case, we can write it down as, because the velocity is in opposite direction to the velocity of initial velocity, so we are putting negative sign over here. So the final velocity, which is equal to 0.4 kilogram 15 into 15 meter per second, which is the final momentum, which is written in red, minus, that means this minus will come over here, minus 0.4 kilogram into 15 meter per second. That means it's the initial velocity and momentum as well. So when both of these values basically are same but in opposite direction, that is why the negative sign is there. So we add these two momentums before and after the collision. So what do we get? We get, for this value we have the value of 6, that means 0.5 0.4 multiplied by 15 is equal to 6, and 0.4 multiplied by 15 is also equal to 6. So what do we get? Basically the change in momentum will be equal to 2 into 6 Newton seconds. That means in negative direction is the momentum. The momentum is basically moving in this direction, that means in the direction of the final velocity. So the negative sign is only for the direction part, but the magnitude of that momentum is basically 2 times 6 Newton seconds, and that is basically our answer, which is 12 kilogram meter per second, or we can say it as a Newton second as well. So here we go. It is, the answer is going to be 12 kilogram meter per second. So our first answer is absolutely right. Moving on to the next part, average velocity or average force, you can say in this case. So F is equal to delta P divided by delta time. That means the change in velocity, momentum divided by change in time. Now already have the value for change in momentum, and we already have the time also, how much time it took to be in contact with that ball. So if we calculate it, F is equal to 12 kilogram meter per second divided by 0.045 second, what do we get? We get the force which was experienced by that ball is going to be 266.66666 newtons, and that much force, if we round it off, our answer will be equal to 266.7 newton, and this is our answer. So here we have the solution for the question number 4. Let's move on, which is rounding off 266.7. Let's move on towards the 5th numerical, which is also very important numerical, very conceptual kind of numerical. One ball of mass 0.600 kilograms traveling with 9 meter per second to the right collide with the head of the elastically with the second ball of mass 0.300 kilogram traveling with 8.00 meter per second to the left. After collision, what are their velocity after collision? That means after collision, what are their velocities? After collision, you have to calculate both the velocities of both these balls. And he says that the velocity of the first ball is going to be minus 2.33 meter per second, which is to the right, and it is minus 14.67 meter per second, which is to the left. Now, what does he mean by this situation? Now, let us read the question by imagining the whole thing. Now, one ball is of 600 kilograms. You can write it like this. So, not 600 kilograms, 0.600 kilograms. So, let's assume that this M1 is that mass of the ball. And it is traveling with 9 meter per second, and it is to the right. That means it is right of the screen. Here we go. It is towards the right. And in the next case, he says that it is basically head-on collision with the second ball of mass 0.300 kilogram traveling with 8 meter per second. That means we are talking about this ball, and it is to the left of the screen. So let us write down left over here. So it is clear where the balls are situated. So this is the right and this is the left on your screen. So it is it has a velocity of 8 meter per second. Now he says they basically collide. Let's collide them. Yes, they collided, and after collision we want to calculate, and this is the collision part. There's a whole explosion and the velocity have changed and they'll move in opposite direction, but we don't know that yet, that where they will move. We have to calculate the direction where they will move basically in this case. So let's see where they will move. So let's assume that the mass of the first ball is M1 is equal to 0.600 kilograms. The velocity of the first ball is equal to VI, which is 9.00 meters per second. Mass of the second ball, which is in green, m2, is equal to 0.300 kilogram. Velocity of the second ball, which is v2, which is equal to 8.00 meter per second. We have to find basically velocity after the collision of the first ball, and we have to find the velocity of the second ball after collision as well. For that, we have a formula. V1 dash is equal to m1 minus m2 into v1 divided by m2 plus m1 plus m2 2m2 into v2 divided by m2 plus m1. We have derived this formula, but basically it is the velocity formula after the collision for the first body. Similarly, for the second body, we have v2 dash, which is equal to 2m1 into v1 divided by m2 plus m1 plus m2 minus m1 divided by m2 plus m1 into v2, and this is the formula which we are going to basically solve. But here's a twist: the direction is the most important thing. In physics, we know that the negative sign basically shows the direction against the motion of the body. Of any kind of against motion can be represented by a negative sign. Now, in this case, we are taking the second body to be negative. That means for the first body, the direction is positive, but it is moving against the second body, because the second body was moving against the first body. That is why we are putting the negative sign over here, so that we can show that the second body was moving against the velocity of the first body. The direction was opposite. Now let us put the values in this same formula. What do we get? M1 has the value of 0.600, M2 has the value of 0.300, velocity V1 has 9 meter per second divided by M2, which is 0.600, M1 has the value of 0.300 plus 2 into 0.300, which is M2, minus 8 meter per second, because this body was moving against this body. That means M1. So this direction was opposite, divided by M2, which is 0.300 plus 0.600. After putting in the values, what do we get? The answer comes out to be minus 2.333 meter per second, which is our right answer. And as we know that it basically moved towards the right again. The body, the first body, this M1, basically it moved towards the right again. The negative sign is showing that it moved back. Now coming on towards the second body, which is over here, M2. For that, we have the formula. For this, we have to put the velocity over here, V1, because this body was moving against right over here, against this velocity of this body. That means they were opposite to each other. That is why I'm putting negative sign with V1, because it was against the velocity of V2. So putting in the values, what do we get? We get 2 into m1, which is equal to 0.600, and this negative sign, the negative sign, that means this body m1 was moving against m2, divided by 0.300 plus 0.600 plus 0.300 minus 0.600 into 8 meter per second, which is the velocity of the second body, divided by 0.300 plus 0.600. Now let us clear that up so that we have the answer. So the answer for the second body is going to be V2 dash is equal to minus 14.67 meter per second. And as you know that it went towards the left hand side of the screen, so our concept and our answer was right. Imagination was also correct, which we thought that it will move in that direction. Moving on towards the next question, which is about projectile, which says, in a wedding, a bullet is fired in air with a speed of 500 meter per second, making an angle of 60 degrees with the horizontal from AK-47 rifle. The spelling of the rifle is wrong over here. Let me correct it. It must be 2 F's, I think. If it is not, just please say something in the comments. No problem. Rifle. How high will the bullet rise? This is the first question. That means what is the maximum height of the bullet? And B part is what would be the time taken to reach the ground. That means what would be the time would take to reach the ground, the time of flight of that projectile. And the last part, part C, says how far would it go. That means the range is also required. So ignoring the air resistance, there is no air resistance. So here we go. The answer of the height is 9,560. The answer for the time taken is 88.3 seconds, and the answer for the range is 22,078 meters. So we don't care about the answer as much as the procedure. So we have to calculate what is the answer. I think that we have to imagine it first, that what we are talking about. First of all, let me tell you what is AK-47, and then we move on to this part. First, we'll know the data given to us. The velocity of the bullet is 500 meter per second. The angle of projection which is given to us, which is 60 seconds or 60 degrees. Now this is AK-47. This is a rifle, AK-47, which is the rifle we are talking about. So we have to use this rifle in the wedding, and this rifle basically makes an angle of 60 degrees with the horizontal. Here's a 60 degrees, and here's a bullet. And when it is fired, we have to calculate three things basically: how much far it goes, how much high it goes, and what is the time. This is the trajectory of that projectile. So we have to calculate three things: the maximum height, which is h maximum. We have to calculate the time of flight, which is t. We have to calculate the range of projectile also. So maximum height we have to first calculate. Let's calculate the maximum height. For maximum height, we have the formula: h is equal to v naught square sine 2 theta divided by 2g. Putting in the values, what we get? We get h is equal to 500 square sine square into 60 divided by 2 into 9.8. Putting in the values of g. So its value will be 100,000 into 0.75 divided by 2 into 9.8. So multiply this 100,000 by 0.75. What do you get? 187,500 divided by 19.6. We get an answer that 9,566 basically. So it is round about 60 meters away or 6 meters away. So our answer is taken to be as correct. So we have calculated the height of the projectile, the maximum height. Now for the second part, the time of flight. We have already calculated the height, which is 9,566. Now we have to calculate the time of flight. The time of flight has a formula: t is equal to 2v naught sine theta divided by g. Putting in the values, we get t is equal to 500 into sine 60 divided by 9.8. When we put in the values, the time will be equal to 88.36 seconds, and that is the time required by the projectile to reach from point A to point B. The last part of this question, the range, has to be calculated as well. For that, we have again a formula for the range, which is r is equal to v naught square divided by g into sine 2 theta. Now putting in the value of theta, what do we get? We get v naught, which is 500 square sine 2 theta, which is 60 degrees, divided by 9.8. We get 25,000 multiplied by sine 120 divided by 9.8. The range is 25,000 multiplied by 0.866, which is the sine of 120, divided by 9.8. The answer is 100,506.35 divided by 9.8. So the range is calculated out to be 22,092.48 meters, which is approximately close to our required values. So this is the range which we have already calculated, and the range can be shown from here, from point where it was basically propelled to the point where basically it impacted. So this is the range which is calculated out to be 22,092.48. This is the answer. In a similar question is a catapult now. Now, what is a catapult? We'll see that in a little while. A catapult hurls a stone of mass 32 grams with a velocity of 50 meter per second at angle of 30 degree of elevation. What is the maximum height reached by the stone? What is its range? How long the stone been in air when it returns to the original height? That means we have to calculate again three things. Number one, the height of the projectile. Number two, the time of flight. And number three, the range. For that, let's assume first the data which gives us the values, which is the mass which we have to do, which is 32 grams. We convert that grams into kilograms, so we divide it by 1000. It will be 0.0032 kilogram. The velocity of the stone is given to us is 550 meter per second, and the angle of elevation, that means how much elevated it is from the horizontal. This is the angle of elevation, which is shown by 30 degrees right over here. That means it is above the horizontal point. It is moving the anti-clockwise direction. In anti-clockwise direction, the angle of elevation is shown in this diagram. Now, in this case, let us assume what was catapult. Now, this is the diagram of catapult. That means you put something over here, and it is basically propelled and goes down to large distances right over here. So this is basically the concept of catapult. It was used in olden days. Now let's assume that we short it a little bit so that it fits into our diagram. So let's keep it for far away so that we can see the whole procedure, that how much far away we can throw the object. To find the time of flight t, we have to find the formula first. We have to find the maximum height. We have to find the range of the projectile as well. So it is making an angle of 30 like shown over here. So it is making an angle 30. We put in the object over here. This is the object right now. And when we throw it, it covers basically a certain height and it goes a certain range, and we have to find the time as well. And this is the trajectory of that projectile now. Now for the time of flight, let's calculate the time of flight, that how much time it took for the body from move from point A to point B. Putting in the values of t, it is going to be t is equal to 2 v naught sine theta divided by g. Putting in the values, we get 2 into v naught, which is equal to 50 sine 30 divided by 9.8. So the t is taken out to be 5.1 second. That means the object or the stone basically which was thrown from here, it took 5.1 seconds. So here it is 5.1 seconds. Now we have to calculate the maximum height, this part. For the maximum height, again we have a formula, h is equal to v naught square sine square theta divided by 2g. Here we have h is equal to 50 square, which is v naught square sine square 30 divided by 2, 9.8. What do we get from here? H is equal to, basically taking square of 50, it will be 2500 into 0.25, which is the sine of sine square of 30 divided by 2 into 9.8. What do we get from here? We get 625 divided by 19.6. It will be, height will be, the maximum height will be 31.8 meters. That means this much is the height of the projectile. So the maximum height it has reached is 31.8 meters. Now for the last part, for the range part, we have the formula for the range. R is equal to v naught square divided by g into sine 2 theta. Putting in the values, we get R is equal to 50 square divided by 9.8 sine 2 into 30. What do we get? We get R is equal to 2500 divided by 9.8 sine 60. The value of sine 60 is taken out to be 0.866 into 2500 divided by 9.8. So multiplying these two values, 2500 and 0.866, what do we get? We get 2165.0635 divided by 9.8. When we do that, we get a value of the range, which is 220.9248 meters, and this is the range of that projectile. And this is how we have completed all the question of chapter number force and motion. Inshallah, we'll meet again. Allah Hafiz.